Hey everybody. So today I just wanted to walk through basically how we can do some kind of static application security testing in LabVIEW. So out of the box, there's really not a way to do static application security testing. There is VI Analyzer, and that is really intended for static code analysis, and it works great. There are some quirks to fine tuning it for what you really need so that the results are helpful, but it works great. But out of the box, right, there's not really tools for allowing you to scan, for security related items. So you can, though, create custom VI Analyzer tests, and you can use VI Analyzer to run those custom tests and detect different things. So it does kind of require a little bit of knowledge of VI scripting to be very effective with it. But once you set up these tests, you can use them to basically do automated security testing of your code. So here I have a list of just some that I've created that are just security related tests. And all of these that are here, I actually have published to my GitLab. The link to that repository is in the description of the video if you want to play with these. But basically, yeah, the idea is we want to have tests so we can do some security automated testing without having to manually go VI through VI in your code and look for security issues. We want that to be, automated. And this isn't 100% automated. This is what I would call semi-automated, right? And I'll explain what I mean by that in a second. But yeah, so we have things like, let's open this hard-coded database credentials. So this is going to pop up, this LLB. And this top one here is our actual test. This is what VI Analyzer would run. So let's look at what it's doing in here. Very first thing, we're just opening a reference to the VI. And this here is just saying, does this VI have a block diagram? So it's using a little bit of VI scripting to see if it has a block diagram. The point being, if it doesn't have a block diagram, we can't do analysis on it. So that would put it into this case here, in which case we just close out that reference. And this returns a result that just says this VI doesn't have a block diagram and therefore cannot be inspected. So yeah, we're just saying, hey, you can't actually scan this VI because we can't see what's going on in the background. If it does have a block diagram, though, we are if you turn on VI scripting, this is the traverse for GObjects function, and we're looking on the block diagram for sub-VIs. And then we are just iterating through all of the sub-VIs to see if the database tools open connection function is there. And this is polymorphic, so it either works with a path or a string, so we're checking if either of them are there. If they are not there, we're just saying, hey, that the database connectivity toolkit isn't used here, so no worry. It passes the test, and we're outputting a 1. So yeah, just saying, hey, they didn't even use that here, so there's no risk. So you can use this to scan your project. Your project could have hundreds of VIs, so that way you're safe on hard-coded database credentials on VIs that don't even use the database functions. Now, if that open connection function is there, we're going to retraverse for string constants, and we're going to just here do a little typecast to a string constant, and we're going to get the wire terminals, and then we are just outputting the name, and we're checking if that name is either connected to the user ID, the password, or connection information. So those are the actual terminals on, if you go open database connectivity toolkit, open connection, the user ID, the password, and the connection information. So if you have a constant wired to those, it is going to throw a failure at you that just says, hey, there's a constant connected here. And it does let you know, right, there's a potential to leak credentials. So you might want to check that. So Doesn't necessarily mean that there is a direct security issue, but it highlights that you need to go look at this and make sure that there's not. And if there's no hard-coded database credentials, it just gives you a 1 and says, hey, this passes, right? There's nothing, everything is either dynamically being passed in through different functions and controls, or it's using like a dialogue or something like that. So, but yeah, if there are constants just connected to this stuff, it'll flag it. So, you can do a further analysis. So, ideally, right, this is used for detection more so than total approval, right? And as I get into some of these other functions, you'll see more of what I mean. So let's look at like detect TCP usage. Let's open this one up. Using TCP by itself isn't necessarily a bad thing. But if you're transmitting sensitive data, using TCP by itself isn't good enough. We need to be using the TLS functions in addition with the TCP functions to ensure that data is being transmitted securely. And so there are TLS functions that ship with LabVIEW, and there are additional TLS libraries that are available on VIPM that people in the community have come up with. So not wanting to basically lock us into just one of those, this is set up so it will detect if TCP is being used. So if the TCP open connection is being used, we can flag what VI is opening that connection, or nothing at all, right? So that way we can basically drill down into that specific VI and make sure that either A, the data that's being transmitted is is not important data, right? It could be totally fine to be sent unencrypted over the network. In which case, don't worry about it, right? This VI isn't making the call for whether your data is sensitive or not. But it is just being used to detect if TCP is being used, so you can then know which VIs to look into for your kind of security testing, which is why I said this is semi-automated. It's doing all of the discovery for you, and basically you can, from the results, then just have a couple of VIs you actually need to go look into and certify that, everything's secure. So this is just pulling the diagram and all objects on it, looking at the class name. And I have a couple different options here, right? If it's a function, we're pulling the label. If it's a sub-VI, we're pulling the VI name. If it's polymorphic sub-VI, pulling the VI name. And if it's a shared variable, we're just outputting shared variable. Basically from there, it's just going to look if the TCP open connection was used. And if it was used, we're going to report a failure and say, not saying, hey, there's a security vulnerability here, but saying, hey, check to ensure that either data being transmitted is non-sensitive or that TLS functions are being used. And even outside of TLS, there could be external encryption being applied, right? You could encrypt the text manually before you put it into a TCP function and then decrypt it on the other side. So there's different things you can do to secure that. And this isn't making the call directly of, is this code secure? It's just helping you detect, hey, these functions are these certain VIs are what you need to take a look at for your, in like a peer review or something like that. So, that would be kind of what it does. And I have a whole bunch of different kind of protocols here, right? So it detects UDP, TCP, shared variables, network streams, IRDA, data sockets, Bluetooth, SQL, FTP, SMTP, HTTP, etc. One other one I want to show is just OS injection. So trying to be able to detect if there's a possibility of an OS injection. So this is kind of similar to the first VI I shared. So we are, basically just checking for string constants. If system exec is present in the VI. If it's not present, you just automatically pass the test because there's no possible OS injection. But if this is used, we want to look for string constants. And if there are string constants, we want to see if they're connected to the command line terminal on system exec. And if they are, then there's no risk of a OS injection, right? Because it's just a string constant. It can't be manipulated. It can't be changed. So it's the only instance in which there is absolutely no possibility of an OS injection. Now, if there's not a constant, that doesn't necessarily mean that there could be an OS injection, but this code isn't, you could try to make it follow the wires and the controls back, and, that could even go several layers deep in sub-VIs and whatnot. You could set it up in such a way that it could go, further back, but it says, hey, if there's not just a constant connected, there's a potential for a OS injection. You need to go verify that. So again, this isn't saying whether this code is secure or not, but it's just completely ruling out whether there's the possibility of an OS injection or not. And if there is a possibility, it will mark the test as a failure, so you can go review which specific VIs there's a possibility of there being a security issue in. So in our instance, right, we aren't just clicking VI Analyzer and loading our project. We kind of have a custom interface with a custom config file that will run these tests. And as there's a failure, right there, it can mark which VI was a failure, and I can go click down into it and open up the specific VI, so I can see like, oh, that's the VI in question, and I can either certify that, and basically on the VI front panel as well, we kind of have a checklist of just stuff, so I can go click, through the checklist and certify that I manually inspected that these things were compliant, and it will generate its own report outside of VI Analyzer with those specific test results. So we're not actually using these test results to determine pass-fail. We are using these test results to then either say everything's good or basically push us towards further analysis that we then have a person analyze and certify. So but you're welcome to use these however you want. Like I said, all of these tests that I set up are available in my GitLab repository. You're welcome to pull them, use them, modify them, etc. So, it is important that we are doing static security testing on code. It's tricky in LabVIEW though, because there's not an out-of-the-box solution like there is in a lot of other languages. We've got to kind of build those, and hoping, right, as a community, we can kind of all come together and build a good library of security-related tests that can be to everyone's benefit. So, thank you guys for watching.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.